In today's podcast, we will actually construct the perpendicular bisectors, angle bisectors, medians, and altitudes of a triangle and see how they're used. The first example is finding the circumcenter, which is done by constructing the perpendicular bisectors of each side. This is the point that is the same distance from each vertex of a triangle. First, construct the perpendicular bisector of at least two sides. Remember, put the mirror on the side and line up the sides and the end points, then draw the line along the beveled edge of the mirror. You should have something like this. You may have used another side, but that's okay. All 3 points intersect in the same place. Now, to verify, take a compass, place the point of the compass on the intersection and the pencil of the compass on one of the vertices. Then draw a circle around the triangle. It should look something like this. The circle you have drawn should hit all 3 vertices of the triangle. If you're a little bit off, remember we're not exactly using precision instruments to do our constructions. In the real world, you may use the concept of the end center or the circumcenter to locate a plant, a manufacturing plant, so it's equally accessible to all of your stores. When we're solving problems with perpendicular bisectors, there are basically 2 types. One type is the bisector, where we understand that the segment is cut into equal parts. The other part is the perpendicular part, which means the angle formed with the side is 90 degrees. I will now demonstrate how you use those. I'm going to demonstrate with one side, and then you can do the other one as your own example. I'm going to use the one with the x's because this is a perpendicular bisector. I know that x plus 8 equals 3x minus 12. Go ahead and solve this problem, pause the podcast, solve the problem, and then check your answer. I think I made a mistake when I wrote the equation the first time. It's been fixed. X plus 8 equals 3x minus 12. Went through the process of equation solving, and notice the last thing I did was to substitute it back in to the 2 pieces of the side and verify that the sides were equal, 18 and 18. This means that side BC of my triangle is actually 36 units long. Now, repeat the process and find P, then check your answer. Pause the podcast. Check your solution. I came up with side AB was equal to 16. The last thing we could work with are problems that involve the 90-degree angle, and in this case, we could use that information in order to find something else. For example, if I knew that the angle formed between this perpendicular bisector and segment BC equaled 3y, I could determine that 3y will equal 90 and y would equal 30. Now, suppose at the same time I also knew that the longest side of my triangle was y. Then I know that the longest side of my triangle is going to be 30. The next thing we'll be finding are the end centers, and we find these with the angle bisectors. Just as an example, suppose you were a hunter and you're out hunting in the woods and you know there are some roads that you can get to. You want to find a place where you could put your salt lick so that after you successfully hunt your deer, you can transport the carcass to the truck very easily. Well, here's how we would find that. First, we're going to construct the angle bisectors. Remember to do that, you place the mirror on the vertex and then line up the sides of the angle. Do that now. The point of concurrency for the angle bisectors is the point where we would want to put the salt lick. To verify that this is the same distance from each of the roads, you could actually place the point of your compass on the end center and then find the shortest distance to a side and draw a circle. Try that right now. Notice that the point of my compass is at the end center, the pencil of my compass is on the circle, and if I draw on the triangle, and if I draw the circle, you can see that it touches each side of the triangle. That means that that's a distance to each road. The Problems that involve angle bisectors typically are of two kinds. One is involving distances, the other is involving the angles. Either way, the distances or the angles are equal. In this circumstance, I'm looking for the distance from the angle bisector to one side of the triangle. In other words, the distance to the road on one side and the distance to the road on the other side, and I want them to be equal. So x plus 5 will equal 2x minus 4. We simply solve the equation and then substitute it back in. So 5 equals x minus 4, x equals 9. The distance to the roads, on the top side, it's 9 plus 5, which is 14. On the bottom side, it's 2 times 9 minus 4, which is still 14. I know I did the problem correctly because my distances turned out to be equal, and I know what those distances are. Centroids are the center of gravity of an object. In a triangle, you find the centroids by finding the medians. That means we need to find the midpoint of each side. Remember, to do that, you simply lay your mirror on the side and line up the end points of the segment. Then you just want to draw from the vertex to the midpoint of the opposite segment. That point where they meet is called the centroid, or the center of gravity. These are two examples of buildings where they've actually used the center of gravity, or the centroid, in order to determine how to construct the building so that it will balance on a small point. Now, these are obviously more involved than just finding the centroid of a triangle, but the concept is still the same. One of the cool things about the centroid of a triangle is that it's located 2/3 of the way between the vertex and the midpoint, and this is how we'll solve problems involving centroids. Basically, what this means is that the distance from the vertex to the centroid is going to be twice as long as the distance from the centroid to the opposite side. So let's write that down. The vertex to the centroid equals twice the centroid to the side. Now, we'll go ahead and use the values of y to set this up and solve it. What it means is this: the distance from the centroid to the vertex was 8y minus 6, and that's going to be twice as long as the distance from the centroid to the side, which is 3y plus 1. At this point, we simply solve the equation. Pause the recording and do that. You should have gotten y equals 4 for your solution. That means the length from the vertex to the centroid is 8 times 4 minus 6, which is 26, and the distance from the centroid to the side is 3 times 4 plus 1, which is 13. Notice 26 is 2 times 13. Pause the recording, find the values of x and z, and check your work. Check your answers against the work at the board. The last thing we'll look at is finding the orthocenter, or the intersection of the altitudes of a triangle. The orthocenter is that point of concurrency. The problem with the orthocenter is there really is no good use for it. It's just kind of a neat point. So let's find it. Remember, to find an altitude, it's the same as finding the distance from a point to a line. So first, we have to extend the side of a triangle to get the line that contains that side. Then we need to construct the perpendicular from that point to that line. Be sure that you extend your perpendicular beyond the line, because we're looking for the place where the altitudes actually intersect each other. You need to do it for two sides, so we'll do the same thing from two sides. And end up with the orthocenter. It's a neat point because it's on the 9-point Euler circle, and it also happens to be collinear with the end center, the circumcenter, and the centroid. The main idea with the altitudes is that they form 90-degree angles, so we can just use this to find the value of a variable and then use that value to find other answers. So from our example above, if our altitude comes down here and creates an angle of 3x minus 9 degrees, because it's an altitude, I know it's a right angle, so therefore 3x minus 9 equals 90, 3x equals 99, and x would equal 33. Now if I want to find the length of the side up here, which is 5x plus 20, 5 times 33 plus 20 works out to 185 units long. This concludes today's podcast. At this time, please begin working on the worksheet Skills Practice for Section 5.1.